Να κλείσω. Ξεκινήσουμε. Okay. Alrighty, so, guys, let's shut the door and let's get started. There's a door in the back as well. You can push people that side. Okay, so welcome back, everybody. I trust you're all being caffeinated and you're all ready for our next session. It's our final session this afternoon in this room before we close. Can I introduce Panos Astithas, who is a Firefox Engineering Manager at Mozilla. Welcome.
Thank you. So good afternoon, everybody. I hope you had your coffee. We are going to talk today about security and privacy for web applications, a topic that is near and dear to my heart. The couple of things that you might be interested to know about me is that I am a Firefox Desktop Engineering Manager. I'm working at Mozilla, and I've been there for more than 6 years now. This is my 7th year. And my previous assignment was as the manager of the privacy and security team at Mozilla. This was one of the most exciting things I've done at Mozilla, and this is because I think the concept and the problem space of internet online security is so important right now. And you might ask, how important can it be? Well, apparently it's important enough to almost want to make us cry. I don't know how many of you are, quick show of hands, how many of you are familiar with the recent WannaCrypt ransomware attack? So I'll spare you the gory details, but suffice it to say that it was a devastating attack to a number of important institutions. And this wasn't just a one-time thing. This graph shows the number of user credential leaks in the past few years, and they are in the order of billions. And it doesn't go that far back. It's like mostly in the past decade or so. The one from Yahoo in 2013 definitely tops the charts there. Let me try another quick show of hands. Who among you thinks that having control over the information that is shared about you on the internet is an important thing? All right? You will see that you are not alone in that sentiment. Recent research in the United States by the Pew Research Center shows that 93% of people responded that they think being in control of who can get info about you is important. 90% responded that controlling what information is collected about you is important. And even half of the population in that survey is worried about the amount of information available about them online. So clearly, that is a big topic. And this demand led to more legislation around data protection laws. As you can see, this heat map here, around 2/3 of the entire world have enacted comprehensive data protection laws, including this country. And the countries in green are in the process of doing so. So security is obviously super important. And in this talk, I will try to go for breadth of coverage, not depth. So expect to hear a lot of bite-sized information for too many things, which I hope will be more useful to you all. And let us begin with encryption. A topic so controversial that once had people print algorithms of encryption in their cans, their t-shirts, or their bodies. There's a lot of positive development in the field of encryption in the past few years, beginning with a broad adoption of HTTP2, which, apart from the performance improvements with multiplexing, pipelining, and all that, it also is de facto TLS only. Only HTTPS connections can be held above an HTTP2 protocol. This is something that browser vendors made sure that happens, and they were also instrumental in shipping the latest iteration of the TLS protocol, TLS 1.3, which I think just began to be rolled out this year. We have been enabled that implementation in Firefox, and we've been testing how it fares with the new server implementations and CDNs out there. So TLS 1.3 does a bunch of interesting things. For starters, it drops insecure features and algorithms present in older versions of the protocol, from 1.0 to 1.2. It brings 0 round-trip time handshake for better latency in your connections. But in my view, the most important part is that it's based in a more sound academic design that has some security proofs and verification effort going on, and that looks very, very promising. In the more technical side of things, the introduction of HSTS and HPKP was really important. I will talk about that in a bit. And the free certificates that are now available all over the world from Let's Encrypt and similar efforts is another huge deal in my view that I will also talk about in a bit. Let's briefly discuss HSTS. Who here has implemented HSTS in their website or web application? Just a few. That's good. That's a positive development. This is not so old, and it is tricky. What HSTS does is it makes sure that every connection that happens from a client to your server will be connected, will be done over HTTPS after the first one. And if your HSTS, if your domain name, is present in the browser's preload lists, it will happen all the time. There's no way for someone to connect to your HTTPS site and be eavesdropped or subject to man-in-the-middle attacks. There's a number of tricky informations here that you need to get right, but it's a big boost to security. Another important development is HPKP. Anyone here implemented HPKP? Just a couple, which makes sense because HPKP is not for everybody. Mostly because it's too easy to get wrong and make a denial of service attack against yourself, but more importantly because this is a kind of attack scenario that can only affect few sites. The thing HPKP protects against is a certificate authority essentially issuing a certificate against another website, another domain that they don't necessarily own. So imagine state actors or government agencies trying to trick you into connecting to their server so they have access to all of your data. This is why HPKP has been instrumental in finding instances of such attacks in Middle East and Far East. In terms of implementation, what it does is that you include in an HTTP header the pins of the public key pins, the public keys of your intermediate certificate authority certs. A much more important thing in my view is Let's Encrypt. Can I see a quick show of hands who here has HTTPS site implementations running in their businesses or organizations? Now the rest of you, what you might not know is that you can do so now for free. If you visit let'sencrypt.org, you can see a certificate authority that is backed by all these great organizations at the right. That is free for anyone to download. That it's automatic. It provides a number of scripts and code that you can run in your web server to have the certificate automatically being renewed, which has been a huge pain point in the past. It is secure. sort of serves as a platform for implementing a certificate authority and as a beacon that other certificate authorities can look up to. And also, it's so transparent that it publishes everything, every certificate ever being issued, every request for anyone to inspect. So if you haven't yet had a certificate, check let'sencrypt.org out. All these developments have had a significant impact in the world we're living. This is the graph of web pages served using HTTPS that Firefox telemetry reports. This begins I think a year and a half ago, and at the end of last year we were at 49%. So I didn't have a nice graph like this one, but I just checked the latest numbers for April, and the number has risen to 55%, which means that more than half of web connections, more than half of page views are now being over an encrypted channel, which is huge. There are some not so good parts about encryption as well. One is that there's still some laggards that still use insecure algorithms like SHA-1, MD5, and all that. If you are one of those, please stop doing that. Upgrade to help us all be more secure. Another issue that has been coming up infrequently is missing intermediate certificate authority certs. So if you have a website that has been certified by a certificate authority that includes an intermediate certificate authority in its signing chain, in its certificate chain, please make sure that when you serve the certificate to the client, it includes the entire chain. Our data suggests that something like 6% of page views fail to complete in Firefox because of missing intermediate certificate authority certs. And the other 2 points that I would like to talk about in a bit more length is the, I wouldn't say prevalence, but the existence of mixed content pages out there, and the tendency of some websites to fight the password manager. So let me start with mixed content. Mixed content, for those of you who don't know, is when a website served over HTTPS contains some parts, some resources, that are served over HTTP. And there are 2 types of mixed content, depending on what type of resource it is we're talking about. So if this is an image that you're fetching over an plain HTTP channel, this is a mixed passive content case, because you have a tag like that in your markup. Now, if this is a script, if it's a JavaScript file that you're fetching, it belongs to mixed active content, because that content, the problem is that that piece of your page can be altered. So what ends up being displayed to the user is not the same thing that you as a web page author were expecting to be there. So if someone alters the JavaScript that the browser loads, it can do all kinds of tricky stuff, which is precisely why browsers block active content by default. If you see Firefox load such a page, you will see that there's a green padlock, meaning that the page has been secured, and the information in the identity panel displays that. And in the case of a mixed passive content, if for example, there are images in your page that are being loaded, you will see that the browser allows that to happen because the danger is, like the risk is smaller. If you are asking what is the risk, when fetching even insecure, even passive content, the browser may send cookies, and cookies might contain state information or your credentials or what have you. So there's still risk to that, and if you're responsible for creation of a website that is run over HTTPS, please make sure that you eliminate any instance of that. Lastly, insecure logins. I think this should be an obvious no-no to everybody who's heard anything about HTTPS. Having content displayed over HTTP over plain HTTP is one thing. Having password submission being done over HTTP is way worse, obviously. So what browsers do, and what we have done, and now Chrome is doing as well, is that it detects those cases and warns the user that this is an insecure interaction. So the trust should be higher as well. There are two things we're doing right now. First of all, we're displaying the strike-through lock in the location bar, and we're also displaying in-context message when the user is going to type in a password field. And these are already bringing interesting results. Firefox 50 was the last version before we introduced any of those measurements, and the number of secure logins in the entire Firefox population was 69%. Since we introduced the broken lock in Firefox 51, it rose to 74%. The introduction of the contextual message rose that to 76% in Firefox 52, and Firefox 53, I just checked the latest numbers, even though it's not the end of the cycle, is up to 78% now. So if you haven't moved away from insecure logins yet, I think it's time you do so. Now, let's move to the second, I have to confess, somewhat arbitrary dichotomy that I've done here, and talk about content security. This is less about protocol and more about the stuff that happens in the page. The most important parts are cookies, CSP, SRI, and web crypto. This is obviously my take on this, but I will cover each one of those briefly. So for cookies, if there's one thing that you can take away from this talk is access to cookies should be limited, both in time, either using the expires tag to set an absolute expiration date, or max age to set a relative expiration date. Strive to make sure that cookies are sent over HTTPS connections only using the secure flag. And in the case where you have to send some cookies to resources that are never fetched via JavaScript, use the HTTP only flag. And lastly, try to limit the domains and paths that are that have the ability to fetch those cookies. There's another more recent development in the field of cookies. There's an experimental draft that has been already implemented in, I think, most major browsers, which allows you to be more strict in the kinds of bad things that can happen to cookies. Now, the problem here is that the cookie specification is so old that nobody dares touch it because the risk to breaking the web is huge. So what they did was limit the number of changes they made to just the name of the cookie. They introduced a set of new limitations, new restrictions to the types of names that are handled by browsers. And if you prepend to the name of your cookie, say you have an SID cookie that is supposed to contain the session ID of the user. If you prepend _secure-SID, that makes sure that this cookie will never be overwritten by an insecure origin. And there are some corner cases where, if you're under an XSS attack, for example, that might happen. The _host-SID notation indicates to the browser that that cookie is to be sent only to the specific host that is being served the page. CSP's content security policy is probably my favorite topic in this section because to me it's like a Swiss Army knife, like a tool that can solve a multitude of problems at the same time. What it does, in essence, is that it limits the place where resources in your page can come from. It can be either an HTTP header, like this example here, or a meta tag in your page. This example, what it does is make sure that no JavaScript code can be inline in your page. So if there was an attack that worked by modifying the DOM to insert a new onload or onClick or something, that will not work. It also limits the places where the page can load fonts from to the fonts.googleapis.com website. Limits the source of images to the origin of the page plus imager.com, and limits the JavaScript and CSS files to that same origin. And a nice cool thing about CSP is that you can provide a report URI where you can monitor for policy violations, which can give you an indication of bugs in your web app or of potential attacks. And a nice thing to remember is that if you're trying to implement that, start not with content security policy headers, but with content security policy report only, just to make sure that you make things work first. Another interesting, but not super useful, I would think, to all of you, concept is CORS, cross-origin resource sharing and sub-resource integrity. So these can be, CORS, for starters, can limit the clients that can connect to a certain page. This is very useful when you are serving APIs, like a REST API or a JSON RPC API. If you implement the first line, access control, allow origin, that specific URL can only connect to your API. If you are a CDN that is serving a JavaScript library, for example, like in my jQuery example below, you need to make sure that that header contains the star, which means everyone is allowed. But one way to protect yourself against intrusion of the CDN network, of the CDN server itself, is to include the sub-resource integrity tag. This integrity field here contains a hash of the file as you expect it to be. So the browser will refuse to load something that has been modified in the server unless that thing matches. And another nice touch is to add the cross-origin equals anonymous key so that no cookies are being sent to the CDN, which is almost never what you want to do anyway. Let's talk briefly about web crypto. I doubt many of you here will be creating cryptographic applications, but sometimes there's a need to do that. And we used to reuse a lot of, honestly, badly written JavaScript libraries out there. But nowadays, the browser provides us better access to the actual operating system primitives. The most commonly abused, the most commonly made mistake in my experience has been to use math random every time you wanted a random number, but not just any random number, a cryptographically secure random number. So the crypto API provides the window.crypto.getRandomValues that will provide you with much more randomness for that. Beyond that, the crypto API contains methods for signing, encrypting, managing your keys, and all that. So if you have use for a cryptographic framework, this is the tool for you. I'm going to quickly go through that list because it's less useful than the previous parts. But X content type options is a useful header to require the browser to not try to second guess the MIME type of the resource it's loading. Sometimes web apps forget to include the right MIME type for each request, and the browser has to do some guessing, especially for older websites. That guessing can be exploited by hackers. So making sure that header is there and making sure that your pages are always served with the right MIME type can thwart that. X-frame options is another header that can limit the frames where your page can be included into, but that can be done with the CSP directive. XSS protection it provides a type of protection against XSS that can also be used by CSP, which is why I consider CSP like the Swiss Army knife of the web securities toolset. And lastly, if you are including iframes in your mashups, consider using a sandboxed environment to load them in. iframe sandbox will, with sandbox display just like that, will make sure that the included frame does not have any permissions. You can whitelist a few of those in additional tags in the sandbox by making, in the iframe, by making the key sandbox have a value of space delimited list of tags. Web permissions is a subject what I spent most of my last year at, so I'm really keen to give you some advice, because web permissions are necessary nowadays in order for our web apps to get access to hardware or the sensors in our systems, things that weren't possible in the past. Things like geolocation or notifications from the browser, push notifications, which are very, very common on mobile, WebRTC with access to your camera, your microphone, or screen sharing. All that requires permission, and there's a huge number of permissions that is being discussed and debated whether to be standardized or not. So there's all these, because they come from a long lineage of standards work, have different APIs for getting permission. There's an effort to sort of unify all that into the permissions API. So if you're writing new code, consider using that. But the thing you should be aware of is that permissions can be blocked if they are depending on how they were asked. Like, was the ask as part of a user action? Was it part of an HTTPS page? And was it part of an iframed page? And I'll briefly touch upon that. I'll just give you a laundry list of things to consider, just instead of getting all the nitty-gritty details out here. First of all, try to avoid asking for permission in the load event handler. You know, that thing when you get a URL in Facebook Messenger and just click on it and it goes to a page that immediately asks for, can I have access to your location? I'm always like, no, I have no idea what this site is for, what it's supposed to do. I don't even know that I care to actually stay on that site more than a couple of seconds. So that is almost never the right thing to do. What works better instead is pre-prompting the user for context. For example, you can check out how Slack does that, where they say, well, you know, Slack works better with permission prompts, and there's a link that you can click, and clicking that link actually prompts for the permission. So the user knows what that permission request is for and what it can provide them. The obvious thing, prefer HTTPS when you're making permission requests. If that's not a thing for you, you will probably have a hard time with some of these newer permissions, and older permissions are being locked down. I think geolocation, even in Firefox, is now locked down to HTTPS origins by default. And the last thing that we're considering blocking is permission requests in child frames. There's a reason for that, and the reason is that we have done some user research, and Google has done some user research, and we have compared our data, and the answer is obvious. When a user goes to, for example, TechCrunch.com, they only understand that they have some sort of relationship to TechCrunch. They don't understand whatever these iframes contained in that page are, who runs them, how trustworthy they are. So the user almost never understands that a permission request from an iframe is from a different origin than what they are seeing as their top-level page. You are not alone if you think that all that I've covered so far is a huge list of things to try. There's the Observatory, and I have a link for that in the end of the presentation, where you can just enter your website's address, and it can run a large array of tests about the security of your page, the TLS configuration, various things. It can provide suggestions of how to improve your standing, and you can actually track your progress in the great history. Now lastly, and I think I'm almost running out of time, I want to briefly talk about privacy. And I think this is a subject that doesn't get enough attention, wrongly in my view, especially if you take into consideration the attitude of users. I have been in a field research study in Germany a couple of months ago, and where we visited people in their houses and asked them how they use Firefox and how they understood the privacy and security trade-offs made by modern browsers. And one thing became clear to me, which is that Germans are very, very interested in privacy. And I think that's true for many other countries as well. The problem, the biggest problem I see is that the web today contains a whole lot of tracking. And tracking across websites. Tracking is problematic because it erodes the trust users have to your company, to your website, your web application. It makes you seem less trustworthy. As I said before, in the TechCrunch example, users only see the relationship they have with the first party, the domain of the page. So if you go to google.com, you understand that you have some relationship with google.com. But if you go to my website, astithas.com, and it contains some Google resources, it's not obvious to you what part Google plays in this deal. So if you have to do tracking, if you want to track your users for accounting purposes or product improvement or whatever, try to do that serving your own tracking scripts. Collect the data you need on your own. The easy way for serving ads, because for ads the answer is exactly the same, try to serve your own ads. Many people just resort to using ad nets because they are so easy to use, and I mean they have great sales teams, I guess. But ad nets can serve malware, and they have, and people have been fallen prey to that malware, and they usually blame the website. They don't understand there was an ad network involved that somehow brought an ad sold by someone sketchy. They only see the thing that's up there in the URL bar. And I would like to make a distinction between protecting against tracking scripts and blocking ads. I think we should try to be more consistent in our separation between the two concepts. Ads are one thing, and we see ads, there are all kinds of ads, and ads don't necessarily have to track you across websites. I don't mind seeing your ad if it's something that's just supposed to, I don't know, take up some of my time or my attention. But tracking me while I visit my online world and getting a footprint of my online life is a completely different matter. If, despite that spiel that I just gave you, still want to use tracking, you need to consider a few things. One is the tracking script may fail to load. If your user is using Firefox in a private browsing mode, they quite likely have tracking protection enabled, which means that your tracking scripts will be blocked. Now that shouldn't mean that your page is entirely broken. It should mean that your page is usable, but the user has chosen to not be tracked. Ideally, you might consider respecting the do not track signal as well. Another thing that is commonly abused is on before unload events, to make sure that whenever the user is moving away from your site, you're doing some bookkeeping activity that always, I mean always, slows down page load times and page navigation. There's a new sendBeacon API, window.sendBeacon, that you can use instead to make sure that any information you want to send to your backend can be transmitted asynchronously. The browser will navigate immediately away, and it will guarantee that your information will be sent without blocking the user interaction and make the web bad for us all. I'm going to quickly gloss over the anti-fingerprinting topic. You know, people use Tor browser. We have been importing Tor browser patches into Firefox, so protection against fingerprinting is going to become a bigger deal in the coming months or years. If your tracking depends on fingerprinting users, you should be prepared to be less able to do that. So be prepared to have much more granular numbers than the fine-grained numbers you have today. And as a help gesture to you, there's a thing called lean data practices that the legal team at Mozilla has put together, which is it's a framework or a toolkit about collecting data for your business and your website that boils down to three major principles. One is staying lean by only focusing on the data you need, not collecting everything and seeing if in the future it might be useful. Two, build security appropriate for the data that you collect, making sure that it's not accessible or easily obtainable by others. And third, engage with your users to help them understand why you're collecting that data and how you're going to use them. There's a link in the end, and it should help you have a more trustworthy business as the outcome of that. A lot of the graphs that I showed you in the beginning of this talk comes from the Internet Health Report. I specifically brought up graphs from the privacy and security section. This is a really interesting write-up for those of you who want to learn more about these topics that I covered today. And this is a completely high level. There's a ton of low-level implementation details that you can find by perusing the developer.mozilla.org website, as well as the security guidelines of the Mozilla security team. And there's a lean data link there, so you can watch later. This is the link for the slides to my talk if you want to watch it. And that's all I have today. Thank you for your attention.
Shall we take some questions for Mr. Astithas? Alrighty, let me just put this down there because I've got to introduce the next speaker. I need that laptop for that, but where was that hand? There he is. Okay. Pass that on.
Hi, nice talk.
Thank you.
It appears that the whole privacy concerns thing has given rise to a market for new browsers. So the Brave browser is quite an example. I'd like to understand how Firefox is going to position itself in this market, if at all.
So I think we have a really good position in the market with our tracking, with our private browsing implementation. I think there's a lot to be said about, which browser is more secure, because there is a ton of details and facets to that question. I think the privacy problem is the less understood one, and that's where I think both Brave and Firefox are trying to make a case for. I think Brave is mostly pushing for, a better ad ecosystem in their own way, and there's others pushing in similar directions. For us, the biggest problem right now is the tracking, and the secondary problem that we're trying to tackle at the same time is the worst performance of the web that is caused by ads, regardless of tracking, just the lousy implementations out there. So I think there's a lot of work to be done by all, and for sure, all the implementations out there, especially the open source one, are exchanging ideas and approaches all the time.
Okay, I have a difficult question for you. So, you're investing time, Mozilla is investing time in anti-fingerprinting. So the question is this, does this mean that efforts such as Google's remarketing, the remarketing trackers, are these effectively gonna die? And if yes, and here's the tricky part of the question, would that perhaps raise a scenario in which some big company like Facebook that has, information like age or spending habits or everything, become more powerful in what it can give to advertisers?
I have to confess I'm not familiar with that Google, was that retargeting? Remarketing. I'm not familiar with that project, but it is true. There are giant companies like Google, Facebook, and others that are dominating our online lives, and things in the internet are not as free or as less concerning as they were 5 or 10 years ago. There's a lot of that, and in that Internet Health Report that I mentioned, and you can read up on a ton of similar points to that. Yes, there is concern. Yes, we're trying to do something about that, but I don't think there's anyone even as well established as Mozilla in the scene that can fix the problem on their own. I think this is something that we all need to get together and fix it.
You mentioned Observatory as a tool that web developers can use to essentially benchmark their websites against common threats. And we've had this discussion internally in my team where, yes, this is useful to do once, but I think a better approach would be to incorporate that into the deployment process of your application so you can do these checks. So in case someone decides to do something that's going to cause a problem, it can be detected immediately before it affects customers. What kind of tools would you recommend to do these kinds of checks, especially if you want to do them internally before you actually deploy your application?
I have to confess that I'm not aware of such tools, and that's mostly because I'm not working on that problem domain. I'm not part of the security assurance team at Mozilla and part of the Firefox desktop team. But I do know that the Observatory, besides allowing you to run multiple checks and check your progress over time, it also allows you to not publish those results. So I think what you could do is run private checks every now and then and compare the results yourself. And I think this needs to be said. It's not necessary to get an A+ on that mark to have done a great job. Google doesn't get an A+. Facebook doesn't get an A+. It all depends on the balance between how broad a reach you want your website or your web application to have. Like, do you care about IE 5.5 users or not? Different companies, different organizations may have different responses there.
Any more questions? Nope. Okay, well, thank you very much, Panos.
Thank you.